Okay, hi everyone. This is the last packet in Unit 7, first video for this packet. So we are going to open up with something called Law of Sines. Now previously we have worked with sine, cosine, and tangent when we worked with only right triangles, and that is usually the leeway into trigonometry. You start with the easier concept. Now that we're familiar with the ratios created by those trigonometric functions, we are actually going to apply law of sines, and the incredible part of this is we can use it with any triangle. So I'm going to read from the paper here just to give us an introduction again. We have practiced using trigonometric ratios to find side lengths and angle measurements, in right triangles. The law of sines shows the proportional relationship between angles and their opposite sides. It can be used to find side lengths and angle measurements for any triangle, okay? So given that triangle ABC, sine of angle A, and notice that A is capitalized, which means it's referring to the angle, is going to be proportional. Oh, that's not what I wanted. So sine A over side A, which is in lowercase, is going to be proportional to sine B opposite the side B, which will then also be proportional to sine C opposite its side C. Okay, again, that might be like really convoluted before we actually start working into it, but let's look at problem number 1 and get some examples through the way. I, again, apologize for not being able to explain why these things are, partly because we don't have enough time in a video, and then partly because it is very in-depth. So if you're interested in understanding why this relationship exists, I would encourage you to seek that knowledge out, YouTube it, Khan Academy, etc. So looking at number 1, I know I'm using law of sines, so I'm going to use sine. And I'm going to start with 71. Just no reason, just want to use that. So remember, sine is opposite over, actually, I'm sorry, we're not doing right triangles anymore. Whoops. So sine of 71 over its opposite side, which is x, will be proportional to another angle in that same triangle, sine of 35, and its opposite side, which is 12. Now, if you weren't comfortable using sine and cosine and tan in the previous one, I don't know what to tell you because the stuff's not going away. This is normal cross multiplication. So all I need to do is cross multiply these values and organize it very, very well. So I have sine of 71 times 12 equals sine of 35 times x. Now, keep in mind that x is what I want to get by itself, right? So what I'm going to do is divide the right side by sine of 35. And I want to remind you again, these are not just letters, these are actually numbers. So sine of 35 divided on this side. Now, when you put this in your calculator, please be very careful with your parentheses and such. We're basically going to get another approximate value. X is going to be approximately 19.8. Please, please, please make sure you're rounding to the nearest 10th place. And that's it. That's really it. I think that the most complicated part of this is understanding that you are going to see trig ratios in equations, but you should be treating them like numbers. Okay, so that was number 1. Let's do number 4 also just as another example. So again, I have 53, 96, and a missing angle. So let's see if I can work with this. I have 96 and its opposite side, so sine of 96 over 27. And then I have 53 and its opposite side. But oh, look at that. I don't actually have anything here. So that means I can't use this angle, which means I will have to use this angle. And you might say, well, how do I find that angle? Well, that goes back to unit 2. I have 53 here and 96 here. I can find the missing angle, which is 31 degrees. Write that a little neater. Okay, so I'm actually ignoring the 53 and I'm going to work here. So sine of 31 opposite is going to be sine 31 over x. Okay, again, just cross multiply. Sine, I don't want to work that, I want to work in black. Sine of 96 times x equals sine of 31 times 27. Okay, divide both sides by sine of 96, and x's value should be approximately 14, or exactly 14. I'm not quite sure if it was a clean answer there. And that's it. Make sure for 5 and 6 you're also finding those missing angles because they will be relevant for that. And then the next page is 7 and 8 at least are the same mixed review. And let's do a sample of where we have to find the missing angle measure. Okay? So in this case, let's look at 9. I have 77 and it's opposite. So sine 77 over 14 equals, in this case the angle is missing, so it's going to be sine x opposite 9. Rules don't change, just go ahead and cross multiply, and I'm going to get sine of 77 times 9 equals sine x times 14, right? Now, in order to get x by itself, I'm going to go ahead and divide this by 14. And I'm just going to switch things around. I will end up with sine x equals, this is going to be a value of 0.6264. So go ahead and get that actual decimal value. And then remember that when you're trying to find the angle degree measure, we use inverse sine, right? So x is going to be sine inverse of 0.6264, which will be approximately 38.8 degrees. I wish I had like a calculator function here on it so I could show you what I'm clicking in order to find that. But this number 9 is like, it requires like 2 steps basically. So every time you're finding a missing angle and you're using trig, you want to use the inverse function of that trigonometric function, okay? All right, so that is finding using law of sines. There's plenty of practice for you to do there. The next video is going to be law of cosines. I'll see you then. Bye.